So the final thing we're going to do is complete operations with scientific notation. So you can technically do this by hand without a calculator, so I'm going to talk to you about that. But then you could also really just do it in the scientific notation in the calculator that you're going to have in the scientific calculator, because you'll have one for the state test, so you might as well know how to use it to your benefit. So if I want to add or subtract two numbers in scientific notation, the important thing is that the exponent on the base 10 has to be exactly the same. If they don't have a common exponent, we have to fix them to make them have a common exponent, and then we can add or subtract the expressions out front. So use the little acronym that I told you about, the LARS, to help you remember how to fix it. So in our first example here, 10 to the second, 10 to the second, those are exactly the same. So really we just add 3.4 plus 5.2, and that gives us 8.6 times 10 to the second power. And that would be our answer because they already matched. The important thing here is that we also check the number out front. There's still only one digit to the left of the decimal, so this is proper scientific notation form. So the final answer is 8.6 times 10 to the second power. If you had a scientific notation calculator, you could just type that in using the scientific calculator that we have in the classroom. Just make sure that you put each individual scientific notation in its own parentheses, because if you don't, then sometimes it will add the things next to each other and get things completely out of whack. So by putting it in parentheses, you make sure it does the order of the operations that you want it to do. So the second example, we have a base 10 with an exponent of 7, base 10 with an exponent of 6. Those are not the same. So we need to make them the same. I have two options. I can either make a 7 into a 6 or a 6 into 7. Doesn't matter. If I want to make a 7 into the 6, I need to subtract 1. So if I minus 1, I got to remember this little acronym. If I want to subtract 1, I have to move the decimal to the right one. So moving this decimal to the right one would give me 95 times 10 to the 6th power. And then this is already 6, so plus 1.1 times 10 to the 6th power. Now they match. I would do 95 plus 1.1. Remember, back in elementary school, you had to have your decimals lined up. And this is really 96.1 times 10 to the 6th power. Well, because I chose to make them both into 6s instead of 7s, I have to watch my final answer here because I accidentally have 2 digits to the left of the decimal. So to fix that, I have to move this decimal 1 back to the left. Remember, to the left means to add, so my actual final answer in proper scientific notation is 9.61 times 10 to the 7th power. It was 6, but because I moved it to the left one, I had to add 1, so my final answer is 9.61 times 10 to the 7th. Now I could have, in the beginning, made them both 7s, and I really wouldn't even have to do that at the end. So like I said though, it doesn't matter. You could make them both 7s, both 6s. Just always check your final answer and make sure it's in the proper scientific notation form. So question number 3, I got a -4 and a -5. I can make them both into -5s. So to make it a -4 into a -5, I'd have to minus 1. So if I want to subtract 1, I have to move it to the right one. So 72.4 times 10 to the -5th. And I already see this is causing me to have multiple ones, so if I wanted to change my mind and do them both to be -4s, that's totally fine. You would just have to add 1 to the other one. But since I've already started doing this, we're going to go ahead and finish it. So now I've got matching, and so I'm going to go ahead and add the 3.18 times 10 to the -5th. Make sure my decimals are lined up. So that's really going to stay an 8, and then that'll be a 5, and then that'll be a 5 and a 7. So 75.58 times 10 to the -5th. It's the answer, it's just not in proper scientific notation form. So I've got a 75 in front of the decimal. I need to make it just a 7. So I'll move the decimal 1 place to the left, which means I'll add 1 to the existing exponent. So move it 1 to the left and add 1 The real answer is 7.558 times 10 to the negative 5 plus 1 is negative 4. Last one, negative 3 and negative 2. This time we'll change the negative 2 to a negative 3 by subtracting 1. Actually, let's add 1 this time, sorry. We'll make a negative 3 into a negative 2. So we'll add 1. So if I'm adding, I move the decimal to the left once. So 0.68 times 10 to the negative 2 plus 2.7 times 10 to the negative 2. So that's going to be an 8. 6 plus 7 is 13. So that'll get carried over here. So we've got 3.38 times 10 to the negative second power. And this time, there's only one digit out front. So we are done, and that's the answer. So again, that's by hand. You could just type them into the calculator exactly the way you see them, hit enter, and it will give you the answer. Now, if it's in regular default settings, it's going to give you the answer in standard form. So you need to know how to change your calculator to put it in scientific form. So you'll hit second, that's the little blue button, DRG, and then you would arrow over to SCI. That's how you put your calculator into scientific notation format. If you want to put it back to normal, to put it back to standard, you do almost the same thing. You just have to hit second, DRG, and then you arrow it back over to FLO. That's normal settings, and everything will be in regular standard form. So adding and subtracting, it's the same thing. I have to have a common exponent. If I don't, I need to fix it to have one, and then I could add or subtract the numbers out front. So we'll jump to another example. Example number 7 is the first subtraction problem. We have 10 to the 4s that match, so we just subtract the numbers out front. 8.17 minus 2.6. So that's going to give us 7 minus 0 is 7. 1 minus 6 I got to borrow. So that's a 5. 5.57 times 10 to the 4th power. That's proper scientific notation form, so we're done. Same thing with number 8, they match. You would do the numbers out front, make sure it's in proper form. So when we get to number 9, and they don't match, I need to either make a 12 and 11 or an 11 and 12. Either one's fine. I will accomplish that by moving the decimal using LARS, left add, right subtract. So if I want to make a 12 into an 11, I'd have to minus 1, which means I'd have to subtract, I'd have to move 1 to the right. So 50.2 times 10 to the 11th minus 9.3 times 10 to the 11th. 2 minus 3 I'll have to borrow. So that's a 9. Then that's a 9 minus 9 is 0, and then 40.9 times 10 to the 11th. I have 2 numbers in front of the decimal, so I would have to move it to the left once, and when I move it to the left once, I add. So that's 4.09 times 10 to the 12th. Again, if you can't remember this, type it in. Type it in exactly how you see, parentheses, minus between it, open another parentheses, type it in, close parentheses. It gives you the answer. But you might be in a situation where you don't have a scientific notation calculator that can do that, so you do need to understand how to do it without it. Last 2 operations, multiplying, dividing. This is actually a lot easier if you remember your exponent rules. So multiplying and dividing, you multiply and divide the numbers out front of the base 10. Use the product or quotient rule to change the exponent, and then use LARS to adjust the decimal and exponent to the final answer. So, the product or quotient rule. So since 10 is the same base, it's like those old rules of if I were to have x to the 4th power times x to the 3rd power, I would add them. So if I've got the same bases of 10 and I'm multiplying the whole expression, I can just add those exponents. Same principle with the quotient rule. I would just refer to my old exponent rules of if I had x to the 8th divided by x to the 3rd, I would subtract them and get x to the 5th. So the numbers out front get multiplied. So 2.8 times 1.9, so let's see what that is. 2.8 times 1.9. That's 5.32. And then when I'm doing 10 to the 7th times 10 to the 4th, that's really 10 to the 7, 8, 9, 10, 11th power times 10 to the 11th power. So that's using the product rule. Since 10 is the base and it's the same, we add the exponents. 5.32 is proper scientific notation, so we're done. Okay, we'll try one more like that. Let's jump down to number 6. So 1.64 times 3.5 gives us 5.74, and then we add our exponents. So negative 24 plus 27 is really just a positive 3, so times 10 to the positive 3rd power. Now if this 5.74 had not been in proper scientific notation form, like if it had been 57.4, we would have to use Lars and move it to where there was only one digit in front of the decimal to the left of the decimal, and then adjust the exponent accordingly. If it's already in proper scientific notation form, you do not have to do that. You are just completely finished. Again, you can really type these in the calculator as well. Just make sure you put each expression in its own individual parentheses. So now we're going to take a look at a few division ones. So if I take a look at number 7, I'm really doing 3.72 divided by 1.2, finding out what that is. That happens to be 3.1. And then division rule states that when I divide the same base, I will subtract the exponent. So that's going to give us times 10 to the 3rd power, because 8 minus 5 is 3. 3.1 only has one digit to the left of the decimal, so we're done. So our last example that we'll do with division, we'll do number 12. We're going to do 2.0 divided by 3.2. So that's actually 0.625 times, when we do division, we subtract the exponents. So I have to be very careful because I have a negative here. So I'm doing 6 minus negative 7. So that's really going to give us a result of a positive 13. So times 10 to the 13th power. But I have to slow down. I don't have one digit to the left of the decimal. 0 doesn't count. It has to be between 1 and 9. So we're going to have to fix this. I need to move the decimal 1 over to the right to fix it and make it 6.25. And since I went 1 to the right, left is add, right is subtract, we'll have to subtract 1, and so it's times 10 to the 12th power. That would be the correct final answer. If you're doing this and you think you know what you're doing, you're not sure, you're in the classroom, just type it in the calculator and check it out. See if you've got it right. There's no reason to not use your tools. Okay, so exit slip summary discussion, how are standard numbers written in scientific notation? It's both small and large, so we talked about moving to the left, to the right. It's going to, however many times the exponent's moved affects the decimals moved affects the exponent. If it moves to the left, it's going to be one sign. If it moves to the right, it's going to be the opposite. Question number 2, what are some methods for comparing and ordering? Well, just putting them in the same format. Either put them all in standard or put them all in scientific. If they're in scientific, you can compare the exponents first and then the expressions out front. What are some key tips for performing operations with numbers in scientific notation? If you're adding or subtracting them, you have to have the same power of 10. If you're multiplying or dividing, you do not, because you can simply use the exponent rules, and you can add them if you're multiplying, and then you can subtract the exponents if you are dividing. So you should have an exit slip where you should answer these questions in your own words, and then you should have homework in there for tonight.